Good morning, everyone. Thanks for joining us today. My name is Carrie Pannoni, and I'm with the Maryland Business Roundtable for Education, MBRT, and I am the Next Generation Scholars Program Coordinator here in Allegheny County. I'm excited to bring the next series in our What's Next for Advanced Manufacturing, and I want to welcome today our special guest from the Community College of Baltimore County, CCBC, Jaime Alvarez. Welcome, Jaime.
Thank you. Thanks for having me. Appreciate it.
Well, I want to go over the who, the what, the where, the when, the why, and the how of everything advanced manufacturing so we can help our students plan ahead for what's next beyond high school. And these options are great options for students who have an interest in pursuing a career in this field. So maybe you can give us a little background on the who, and we'll start with that.
Okay. So the who, as Carrie mentioned, I am Jaime Alvarez. I'm the chair of the engineering department at CCBC. I'll give you a little bit of background on myself and how I wound up where I am now. My career now spans the last 23 years since I graduated from Towson University in 1997. My background is actually in geography and geospatial applications, or GIS, Geographic Information Systems. Since graduating from college, I kind of bumped around for a few years, trying different jobs, working for engineering companies, working for government agencies, working for small companies, before I landed back at Towson to work on my master's degree and working at their Center for GIS there, doing what I was trained to do, which is Geographic Information Systems, mapping, GPS, geographic analysis, that kind of thing. Fast forward a few years to 2006 after completing my master's degree, and then into 2007 where a faculty position became available here at CCBC. And for my first 6 years at the college, I was in the classroom. I taught geography, cultural geography, physical geography, but I also taught intermediate and introductory GIS courses, and I taught GPS and what's called remote sensing, satellite imagery, aerial photography, that kind of thing. I spent 5 years doing administration, working at the Essex campus, specifically on all things campus. I was the campus director there before I decided to say, you know, I'm best with students and with faculty, and I was offered the position as the chair of the engineering department in July of 2018. And so I'm finishing up my second year as the chair, and I've been at the college for 13 years now almost, and I love CCBC. I love what we do here, and I think a lot of what I'm going to talk about today is all about a lot of what we do here at the community colleges and preparing students to go out into the workforce, preparing them for bigger and better things, as I like to say all the time, whether that's a four-year degree, a four-year university or college, or some sort of professional training, or going right into the workforce after getting a degree or a certificate.
That's wonderful. That leads us right into the next question is, what programs do you offer at CCBC along the lines of advanced manufacturing and all that encompasses that department? So
yeah, and I'll be referring to my cheat sheet and my own website here. And it's funny because I just have so many programs. When I was brought in as the engineering chair back in 2018, we had several small programs that were already in the engineering department, others that were in what used to be called our applied technology department. And so now I have 8 academic departments, soon to be reactivated, a 9th. And that's going to be in engineering. That's your traditional student who wants to go to a 4-year school and become an engineer. We have engineering technology, which is focused on several areas of concentration. We have geospatial applications. That's my expertise. That's my background. But we also have CAD, or computer-aided drafting and design. We have surveying technology. We have construction management. We have civil engineering. We have HVAC. We have computer automated manufacturing, which is part of what I'm going to talk about here today, and soon to be reactivated and offered at the college starting in the fall again is our design, fabrication, and advanced manufacturing program. And I know we're live here, but I am just going to double check one thing to make sure I did not forget any of my own programs. And that's actually one of the websites that I provided to Carrie to pass out to everyone who's watching, so that you
Sure.
can see all of the different programs that we have available. And I'm confirming here, I'm looking at my own website, making sure I actually did get all of my different programs. So CAD, construction management, engineering technology, geospatial, HVAC, manufacturing, and surveying.
Awesome. That's a
lots going on
lot.
there for sure.
You have a lot to offer students, and this is great. And I know today's focus is on the advanced manufacturing, and you're going to give us some more information on what that looks like. And you've even brought along some props to help with that, and the where this happens on your campus. And you're going to talk more about that in the Fab Lab as well.
Absolutely. So one of our, or a couple of our programs, actually, we have a couple of different programs. I mentioned our design, fabrication, and advanced manufacturing program. That is a program that actually has a degree in those types of technologies. We also have our computer automated manufacturing program, which are which are certificates. They're credit certificates. But within that program, we also have, through our continuing education section of the college, a 6-month short-term machining program. So all of those different areas kind of work together, but are all basically what we have to offer to anyone coming to CCBC who wants to learn about whether it's machining, 3D printing, laser cutting, anything related to these advanced technologies that we collectively call advanced manufacturing. And that's kind of where I wanted to start, because manufacturing has fought this sort of image of being dirty,
Right.
being smokestacks from the past. And that's a common message that you hear out there that we're sort of fighting, whether we're in education or whether you're an actual manufacturer or a company that's manufacturing something. And these days, that really couldn't be farther from the truth. It's extremely advanced. If anyone who's watching has done any 3D printing, you're working with computers. You're working with an advanced piece of technology that is making a 3-dimensional object. You're not cranking these things out like widgets on an assembly line, with Henry Ford smokestacks making cars 100 years ago. That's just not how it is. So there's a lot of advanced technology that goes into what is advanced manufacturing these days. And honestly, it's beyond just the skills that you learn, say, in our continuing education courses or our credit courses, whether it's our degree program or our certificate program, or even an apprenticeship. You may not just be, making something using those particular technologies. You may be in a manufacturing environment where you need to know some electronics. You might need to know something else that one of our other engineering programs at the college would actually teach you. There are assembly technicians and test technicians that test what gets built by other people who know how to use the technology to make those things. And that's, you have to make. I mean, the world makes. We've made a lot of things here in the United States. There's a lot of things that are made all around the world. I'm not going to get into discussions about supply chains and economics. I'm no expert in that by any stretch of the imagination. But, one of the examples I'll talk about today is the PPE project that we've been doing related to the COVID-19 issue, and how we've needed to make things locally due to shortages as a result of that demand around the world, whether it's shields or masks or other things to help protect our first responders, our own staff at the college, for example, or medical staff in a hospital setting.
That's wonderful. And you brought along some of those PPE products that you've been fabricating in your Fab Lab. So please share more with us about this. And you're right. Manufacturing has changed completely over the years, and it's not the same as what it looked like even when we were in school. And so I definitely am looking forward to hearing more about what you've been doing to help out with the PPE and the COVID.
Well, let me, I throw a lot of different technologies out there. We have computer numeric controlled machines that use programming to cut metal, cut different materials to create objects that go into our everyday lives. I've mentioned 3D printing and laser cutting and that kind of thing. So I just wanted to show a few examples of some of those things that when you come here or to any program that might be in manufacturing, what you learn, whether it's 3D printing, laser cutting, machining, sort of those collective tools that are part of advanced manufacturing. Something that I'm particularly proud of. I'm just going to kind of show that a little bit closer to my camera. Well, that's clearly a penguin. That's my personal first ever 3D print. My previous Fab Lab manager, Haley Evans, who was with us up until last year, I had my daughter Daniela in with me one day, and we were like, hey, let's do some fun 3D printing thing. So that's my first ever personal 3D print, and it's up on my shelf in my office all the time. And I like to take it out to the schools and show students that sort of as a primer, because, yay, that's fun. That's a penguin. That's on my desk or on my shelf. It's very novel. But what about creating something that's a little bit more useful? And this is stuff that I take out to the schools all the time. This is a gear that would go into a machine, and this is actually made out of a composite material that replaces the metal gears in one of our machines that we have down in the program. My guys in manufacturing, Bill Wernicke and John Lyons, they're the ones who run our program in our Catonsville program, or excuse me, our Catonsville campus. They have these gears in the machines that the students are learning on. And one of the reasons why we 3D print them is that the gear will automatically snap if a mistake is made, and it will stop the machine. If you have a regular metal gear in there, it'll lock up and potentially create a hazardous situation. So having these snap and break off, and then what do? You go next door to the Fab Lab and you print another one, and you're off and running and back in business, so to speak. But, you know, and to talk about a little bit about the certificates and the degrees that we have, the design, fabrication, and advanced manufacturing program includes some of that machining curriculum that we have where we make stuff, but it also has the front end where we design stuff as well. So I'm not a big fan of the expression soup to nuts, but if you can imagine, you have to design something first, and then you prototype it, you test it out, see if it's going to work, and then you move on to actually producing it. So, you know, I've kind of got this sort of heavy guy here. This is a gear. This had to be drawn at some point and went into some machine that was used years ago in one of our older programs. And again, just one of those things that I love that I throw up on my shelf to show off to anyone who comes in. But this had to be designed. They had to test to make sure that this worked in whatever machine it went into, and then it had to be produced. So that's kind of that sort of progression that we talk about in manufacturing. Before I get into the PPE project with the Fab Lab and with our computer automated manufacturing program, I did want to spotlight, and I know I showed you these things earlier, that kind of progression, if you will, with something that's actually useful and functional. I encourage anyone who's watching to go out and Google Stirling engine. That's S-T-I-R-L-I-N-G, a Stirling engine. This is an example of a Stirling engine. This is a 3D printed. All of these parts are 3D printed, and this is a prototype of a machine that is produced. I'm going to try to kind of get that better into the. Oh
no, that looks great.
So our machining program, our short-term machining program, every student produces what is called a Stirling engine, and this is run by the heat that is produced from some fuel source. So you heat the cylinder here, and it's going to create a pressure differential between these two different cylinders, and it's actually going to make the engine run. Now you're not going to drive a car down the road with the Stirling engine, but they have been used around the world for different uses, using them as small pumps and that kind of thing. But once you're at the point where you're done with prototyping, you might commit to actually producing something in metal. This it was machined by our students, and this is actually a cutaway that actually shows you what the different pistons are doing. I'm trying to find the pistons here, sorry. What the different pistons are doing to actually make this engine work, to actually make it function. Now, because the cylinders are not sealed, this is just a cutaway, and this is just a metal example of the functioning machine. But I'm going to get final here. This is the finished product, and you can see some sort of the soot here on this cylinder where you have a canister with alcohol that you burn that creates that pressure differential. It's hot here, it's cooler here, and you're kind of creating that sort of difference in pressure, which creates that motion that actually runs the engine. I love to show this stuff off because this is what our programs teach our students how to make. And if you can equate this to the stuff that goes into our cars, stuff that goes into our planes, stuff that goes into our everyday lives, you learn here how to make the stuff that goes into everyone's everyday lives, so to speak. So always that stuff. And part of that program, the faculty and staff, along with our Fab Lab staff, have been part of the COVID-19 emergency. And this is just
great.
Everyone who's watching knows the world has essentially blown up the last couple of months. So having access to these technologies and having the staff and the faculty who have the expertise to produce this stuff, we wanted to jump in, and we got the call from OpenWorks, which is a large makerspace here in Baltimore. They have a lot of different educational programs. They have spaces people can rent to actually do their own making. They wanted to basically rally the maker community to make shields to protect first responders and medical staff. So they went the route of a 3D printed effort where they got lots of people together, lots of different organizations who had access to 3D printing, and crowdsourced essentially the creation of thousands and thousands of masks. So we wanted to jump in. My Fab Lab manager, Jen Kim, who actually came to me from OpenWorks, said she was just chomping at the bit back in March. Let me get into the lab. Let us test this. And we 3D printed one of the masks. And over several weeks, we probably did about 8 to 10 of them, because it takes several hours to produce one when you're 3D printing. But we were one of hundreds of organizations and individuals that contributed to OpenWorks efforts. But we have other technologies like laser cutting. And so we have 2 laser cutters in the Fab Lab. And the Fab Lab, of course, not being just a community resource to folks who want to come in and work on their projects, but we also teach our continuing education courses and our degree courses in there as well, as part of the DFAB program and as part of the CAM program, CAM as I call it, Computer Automated Manufacturing. So my staff said, well, there's other designs out there. What can we produce in a short period of time and a lot of? So the first thing that they came up with, and I'm going to show you a quick little prototype, because first you prototype, right? You want to make sure that the design works. So this is actually a prototype that's cut out of acrylic. I went and bought the acrylic for my staff. They said, we need this much acrylic. I said, well, what do you need acrylic for? Don't ask, just go. I showed up with 20 sheets of 4 by 8 foot acrylic. And I said, okay, I got you what you need, but what are you going to do with this? And Jen took this prototype and just stuck it on her head like that. And I went, oh, unbelievable. You can see the connection points right here, and then the point in the back. So if I take the prototype out, and this is what we actually produced. So this is an open source design that came off of the web, and you can see the frame that is a little bit bigger than the prototype that I was just showing you a few seconds ago. And then the shield cut out of a different material. So this is acrylic, and this is what's called PETG, and a rubber band.
Wow.
And there you go. You're protecting your medical staff and your first responders.
That's fantastic. And to see it broken down like that, the pieces that you showed, is fascinating. And you can see how it all comes together, and that these things were produced in your lab where you work with students is fantastic. That you're able, were some students at your school able to help with this project as well? So or with COVID, I didn't know.
Right. Yeah. With COVID going on, we have no student presence. We're starting to open up like the rest of the world is a little bit. But what we did have is we had several staff and faculty who were also socially distanced. I had 2 staff that came in regularly that were socially distanced within the lab, wearing masks, and we're sort of running the project based from the Fab Lab. But I have faculty and staff off campus who have access to the same lasers. And so we had 4 lasers instead of 2 running throughout the process to create these shields. Those same lasers within the Fab Lab actually cut the pattern for our other project, which was a mask project. And you can see sort of the elastic bands and then some of the labeling that we have on there. In fact, this is the one that my wife made for me personally.
Great.
And so this is based on the design that our Fab Lab staff was first cutting on our lasers in the lab, but then sending out to volunteers. And in fact, we even got some reassigned CCBC staff who needed some work to do. Not everybody can effectively work from home. And they said, hey, I can sew. I've got skills. Send me these packs. So they would laser cut them. I would get them to the employee, and then they would send it back for final assembly, adding the elastic, adding the nose piece that goes across the top. And this is 4 or 5 poor people from my department working on this, but then other folks, part-time associates from elsewhere at the college, other folks from our other programs who've said, I've got time, I can come in, I can help. All of these things had to be disinfected and packaged, UV lighting. And so the team, the core team was about 6 or 7 of us, but other folks who have joined in and helped is way beyond I could even mention just sitting here talking to you today.
Oh, sure, sure. So getting back to like, why would students want to have a job in this field? And you talked about some of the skills, but why should they pick a career in advanced manufacturing?
Well, I would argue my first argument that in that it's not the dirty, dirt under your fingernails all the time kind of environment. There's advanced technology, there's advanced skills that you use. You can see products that are made, designed all the way through to production. If you're someone who likes to do hands-on things, and yes, you can get dirty. It's okay to be dirty. It's okay to put your hands on things and learn. And it's not always a 4-year degree. And if that is your path, that's fantastic. We have programs for that. But if your goal is to get some skills and get some training and either get a 2-year degree and go to work, get a certificate and go to work. Short-term machining, for example, is 6 months and is eligible for financial aid. Students can get skills to go out and make things. We have partners as part of a new program that we've been doing called P-Tech, and I know we mentioned that in our discussions initially. P-Tech is Pathways in Technology Early College High School. So these are high school students that are associated with Dundalk High School and eventually Owings Mills, who are learning these hands-on skills but working towards their high school diploma, their degree with us, mentoring from industry professionals, an internship, and first consideration for a job. So one of the reasons, going back to your point or your question, is there's a path there to not just a job, but a career that you could really enjoy. And it could be in any number of areas. Our Owings Mills program that's about to launch in the fall is focused on advanced manufacturing. It's part of our DFAP program. The ones that we have established at Dundalk are electromechanical engineering and civil engineering. In either case, you're doing stuff that is putting things out into the real world, whether you're working on electronics, mechanical systems that are going into machines, whether you're going civil and you're working on bridges or highways or anything where you're creating infrastructure, or design, fabrication, and advanced manufacturing like our own Mills program, where you're making things that go into our everyday lives. There's a good feeling in that. And, sometimes my guys have to just kick me out of their shops and their labs because I just want to go down there and make something, but I have a department to run.
Right. So that leads me to what can students do now? The how can students get into this field? You mentioned the skills and the interests, and if they love hands-on work, this is a great opportunity. But what can they do now to help them? And I'll reiterate that we are going to post in the comments section the links to what you're going to talk about and what you have talked about through this session for information.
Absolutely. There's a number of things that you can do. If you're in middle school, if you're in high school, if you're in elementary school and you want to start kind of messing around with some of this stuff, I'm telling you, 3D printing is becoming ubiquitous. It's everywhere. And in fact, some students might actually start to see it in their schools. A local example that I can give is that I know that the Baltimore County Public Library is training a lot of their librarians in so that they can give classes in how to, or instruction in how to 3D print. And they have a 3D printing service, just as we do here at the Fab Lab at CCBC. There are free software out there that you can start messing around with, tinkering with, Tinkercad being one of them. That's one of the sites that I gave you, where students can start just kind of playing around with free software that's available to start designing things. 3D Space, SketchUp is another one that's free. There's a paid professional version, but you can actually get it for free. My kids have designed things, had some fun with it, just kind of playing around. So you could hit the links to the Baltimore County Library as an example, hit the link to Tinkercad, hit the link to SketchUp to sort of start that sort of the design end of things, where you're learning that stuff has to be sort of creative, whether it was like years ago with T-squares and triangles and tables, drafting tables, versus, you know, say today where we're using CAD software. You can get access to a lot of that stuff now, including some of the cool stuff like 3D printing. We do tours in the Fab Lab all the time for middle, high school students. So it's out there. If you're not in the Baltimore area, you're elsewhere in Maryland, you know, look at your local community college, your local library. There may be programs where some of these technologies are available to you.
That's awesome. Yes, this has been great information. And I think we answered a couple of the questions already in what you what was posted. And just fantastic options for students. You know, they have those options where they can go as little as 6 months to get a certificate program to be able to work in the advanced manufacturing field. And they also can get a degree in the program if they want to continue on. It's flexible. So I love having all these different options for our students and for them to know this. Do you have anything else you want to add to the last, to finish up?
Sure. Well, one of the things that you just mentioned with our short-term program, are as little as 6 months. That's sort of a pre-apprenticeship program to get student skills in a short amount of time. But apprenticeship is growing all over the place. That's a situation where you can actually work for an employer that then sends you back to school with either CCBC or another educational institution to further your education, to move you farther along in what it is that you've been trained on. In our case, it would be a starting point, sort of like a pre-apprenticeship with our 6-month program. Then you find a job, which a lot of our folks, they get jobs right out of finishing that program. And then they have the option to come back with one of our registered apprenticeships with the state of Maryland to work and learn and get paid at the same time. So there's so many options.
And learn.
Exactly. Earn and learn. That's exactly right. So these options are out there in so many different ways. You just got to get out there and see what works for you. If you want to get your hands dirty, get practicing on making stuff, breaking stuff. I always like to break stuff because then I like to try to figure out how to fix it and put it back together. My garage is a disaster, but that's a really good way for a lot of these folks to get started. A lot of these students, younger kids, if this is what it is, if this is what, you know, sort of gets it for you, look into some of the links that I've provided, look at some of the videos, a couple of YouTube videos on the Fab Lab and our manufacturing program, and some other ones that aren't ours, but are sort of, they kind of show you that process of design, prototyping, and production.
Yes, great, great info. Jaime shared a lot of links that we're going to be sharing in the comments. And if you have any questions, don't hesitate. We'll follow up back with you. But thank you, Jaime. This has been a great session on everything, what's next in advanced manufacturing, and students have so many options to think about today, and we're really grateful to you and CCBC and what you're doing for the community with the PPE project. And we just want to thank you for joining us today. And I'd also like to finish up with a couple reminders. We here at MBRT have an app for students, 7th grade through 12th grade. It's a free app they can download on Android or Apple called Way to Be. We've made it new and improved, and we have game-like challenges for students to help them plan ahead for their future. So check it out, download the app, and also join us tomorrow for What's Next in Cybersecurity. So thank you for joining us. On behalf of MBRT, this is Carrie Pannoni, and thank you again, Jaime, for joining us today.
Thanks for having me.
Thank you. And everyone, stay safe, keep social distancing, washing your hands, and take care. Thanks again.